Hello everyone. Today we are going to learn organic chemistry, which students find most difficult. It is an important topic from IGCSE exam point of view. So, organic chemistry is basically dealing with carbon containing compounds. Okay, it deals about the carbon containing compounds. Now where does this carbon containing compounds we get from? So we get it from fossil fuels. We get the carbon compounds from fossil fuels. Now how do we get the fossil fuels? So fossil fuels is nothing but dead organic matter. It is dead organic matter that settle at bottom of sea. Okay, and it is made due to heat and pressure for so much years. Okay, so that is how we get fossil fuels. Now from here, this fossil fuels, we will actually get petroleum, then coke or coal, we can say. Then we would get natural gas. Okay, now we are dealing with petroleum. Petroleum, which is also known as crude oil, which is also known as crude oil. Okay, it undergoes fractional distillation. So fractional distillation is performed. Okay, and it helps to separate. It helps to separate different fractions of hydrocarbons. So petroleum is a mixture of hydrocarbons, okay? And when it undergoes fractional distillation, it actually separates all the fractions of the hydrocarbons based on their boiling point. Based on their boiling point. Okay, so the one with the lower boiling point, we would say lower boiling point, okay, will separate first, or we would say on top of fractionating tower. Okay, on top of the fractionating tower. Okay, yeah, so based on fractional distillation, we would say on the boiling point, all the fractions or the mixtures of the hydrocarbons are being separated in the fractionating tower. Okay, the one with the least boiling point will be separated at the top, and the one with the higher boiling point or melting point would be separated, will settle down at the bottom of the fractionating tower. We are having different fractions that are separated, and all the fractions are having a different type of use. Okay, all the fractions are having different types of use based on the fuel that is being separated. So first we have is refinery gas. So first we have is refinery gas. Now refinery gases are used in cooking fuel. The cylinders that we use or the fuel that we use at home for cooking purpose is nothing but refinery gas. Okay, then next we have is petrol, which is also known as gasoline, again which is used as fuel in cars. Okay, cars and other vehicles, scooty and all. Next fraction that is separated is naphtha. Naphtha is acting as a chemical feedstock. It is acting as a chemical feedstock. So it is kind of raw material to make any other organic compound, we would say. Then next we have is kerosene. So kerosene is used as jet fuel for airplanes. Okay, then we have is diesel. Diesel oil. So diesel oil is used again as a fuel in diesel engines and trucks and all that. Then next we have is fuel oil. So fuel oil is used as ship fuel. It is used in ships. Then we have lubricating oil. So lubricating oil is being used in wax, making wax and polish. Okay. And then we have is bitumen. Next we have is bitumen. So bitumen is used to make roads or the surface layer of roads. So these are the different fractions that are being separated from the petroleum. And as I said that all the different fractions are having a different use. Basically they all are used as fuels only, but depending upon the number of carbon atom, the uses definitely change here. Okay, the number of carbon atoms that each fraction is having is definitely varying. We have carbon 1 to carbon 4, which is in the refinery gas. Okay, then we have carbon 5 or more than that, we would say, in the next fuel. So accordingly the number of carbon atoms keeps on changing. So in kerosene we would say it is made up of carbon 12 to carbon 16 atoms. Then we have lubricating fraction, which contains around carbon 20 to carbon 40, okay, in its compound. So based on every fraction, it is having different use, but they all are used as fuels. It is also used to generate electricity. Okay, now these hydrocarbons that we are learning are again divided into different category based on the bonding they are having. Okay, so we have these three categories, that is alkane, alkene, and alkyne. Okay, so we have to understand one thing, that carbon can make four bonds. Okay, carbon is having 2 comma 4 its electronic configuration, and it is having 4 electrons in its outer shell. Okay, in its outer shell. So it is gonna make 4 bonds. It is gonna make maximum 4 bonds. Okay, now carbon is having a property of making a single, double, and a triple bond. Okay, so carbon can make carbon carbon single bond. It can also make a carbon carbon double bond, and it can also make a carbon carbon triple bond. It is a triple covalent bond, we would say. So carbon is having a unique property of existing as a carbon-carbon single, carbon-carbon double, and carbon-carbon triple bond. Based on all these bonds, we would say hydrocarbons are divided further into alkane, alkene, and alkynes. So we have a carbon-carbon single bond in alkane, carbon carbon double bond in alkenes, and carbon carbon triple bond in alkynes. Basically in our IG curriculum we are not having alkanes. Okay, we are only going to learn about, sorry, we are not having alkynes. We would only learn about alkane and alkenes in detail, reactions and structures of alkanes and alkenes. Okay, so next that we are going to learn before we start with the structures of alkanes and alkenes is homologous series. Next we will learn is homologous series. So what is a homologous series? In organic chemistry we have different functional groups. Okay, we are having different functional groups, and all the functional groups are having so many compounds which are having same type of functional group, so we consider them as a family. Okay, so a family of compounds of different functional groups, we would say, is known as a homologous series. So a family of compounds with same functional group and same general formula is known as homologous series. Okay. So, for example, if I consider alkane, now in alkane I have compounds that contain one carbon atom, two carbon atom, three carbon atom, four carbon atom, and similarly it will go on. Okay, so they all are having a same property in them, that is, they all have carbon carbon single bonding. That is the property alkane family is having. So, we would say all these compounds are belonging to alkane family. Okay, that becomes a homologous series of alkane. Then we talk about, for example, alcohol. Alcohol is having a functional group, that is OH, hydroxy. Okay, so we would say all the compounds that contain OH functional group will belong to alcohol family. So, how to write the names of this organic compounds? Okay, so there is a same type of naming which is being considered for all the functional group, which is being followed by all the functional group. Okay, we are going to use prefixes and suffix to write the name of this compounds. So first of all, we have to understand that how should we use the prefix and what are this prefix. So we have the carbon number and the prefix we are supposed to use. So if I have one carbon, so the prefix used is meth. If I have two carbon atoms, the prefix used here will be eth. If I have three carbon atoms, the prefix used here will be pro. If I have four carbon atom compound, the prefix used will be but. For 5 carbon, it is pent. For 6 carbon atoms, it is hex. For 7 carbon atom, it is hept. And 8 carbon atoms, it is oct. For 9 carbon atoms, it is non. For 10 carbon atoms, it is dec. So these are the prefixes which we are supposed to use. The suffix is going to change depending on what name you are writing, for which functional group you are writing the name. Okay, so the suffix is going to change, but this is what you have to remember from 1 to 10, the prefixes which commonly will be used for naming all the functional groups. Okay, yeah. Now, there are actually different ways by which we can represent the formula. So we can represent the formula in different ways. Okay, so the first and simple way that everyone knows, okay, is molecular formula. It is molecular formula. Okay, so molecular formula is nothing but a compact way of writing all the atoms of different elements present in a formula. Okay, so say for example, I'm drawing a structure here that is of ethane. I would say I will draw a structure of ethane. Okay, so I have two carbon atoms and these are my hydrogens. This is not a molecular formula, I'm just giving an example. So you can see that I have only two elements here, that is carbon and hydrogen. I will write them in a compact way. So I have carbon, I have two carbons, so I'll write C2, and I have total 6 hydrogens here, so 6. So C2H6 is nothing but my molecular formula of ethane. Okay, from this molecular formula, I don't exactly know that how the carbon and hydrogen are bonding with each other and all, but this is the total number of atoms which are present in a compound. Total number of different elements, atoms of different elements which are present in a compound is known as molecular formula. Okay. Next way of representing is a displayed formula. Displayed formula. Now, what I have actually drawn here is nothing but my displayed formula, where I have shown all atoms and bonds, where I have shown all the atoms and the bonds properly. Okay, that is known as a displayed formula. The next way of drawing is structural formula. The next way of drawing is structural formula. Okay, now here what I have drawn, I will draw the same thing again, for example. Okay, so now here you can see that I have drawn a displayed formula. Now, how am I supposed to write again in a compact way? Not like molecular formula, okay? But I will try to write in a straight chain way. So here I will divide the compound in parts. So I have this first carbon which is being attached to 3 more carbon atoms, okay? So we can say that is a group. So I will write it here, CH3 together, okay? Then I have a bond in between. Again, I have a second carbon with a group of 3 hydrogens. So I will write CH3 here. This becomes my structural formula. Okay, this becomes my structural formula. I will write one more example. So for example, I am having, okay, so now here again I will number the carbon so that we will understand. This is my first carbon, this is second, and this is third. Now I will just break all the carbon atoms, I would say. Okay, so this is how, this is my first group, then this is my second group, and this is my third group. Okay, so this is my CH3, then I have a bond in between, then this is my CH2, I have a carbon attached to 2 hydrogens, then I have again a carbon which is attached to 2 hydrogens, so I will write H2, and a OH functional group I am having, so OH. So this becomes my structural formula. Okay, so this is how all the organic compounds can be represented in a molecular formula, displayed formula, and structural formula. From exam point of view, the molecular formula and displayed formula are important. That has been many a times asked in the question, drawing the structure of any named compound, especially the displayed formula. Structural is also asked definitely, but sometimes we would say structural is asked. Okay, but majority times it is either molecular formula or displayed formula. Okay, so this is all about the representation of formulas. Now the carbon compounds that we are going to learn. So carbon, as I said, is having a property of bonding, of forming a single, double, and triple covalent bonds. Okay, not only with carbon but with, we can say, hydrogen, or we can say with nitrogen it can form a triple bond. Okay, it is again having, we would say, two other ways of forming compounds. So one is carbon can form straight chain compounds, or we would say branched compounds, or we would also say it can form ring structures. Okay, so it can have a straight chain compound. So here what structure I have drawn, this CH3, CH2, CH2OH, okay, is a straight chain compound, you would say, okay, where they all are in a straight line and it's continuous one after the other. Then we have a branched chain compound. Okay, now what is a branched chain compound? So it's like this. For example, I will draw a structural formula here. Okay, now here you can see that here I will just number it for better understanding. So I have 3 carbon atoms, and in the second carbon atom, you would say there is a substituent which is present. We can say this is a second branch. Okay, here the structure is being branched. Okay, so this is known as a branched structure. And for ring structures, I would say we are having cyclic compounds. Okay, so for example, I have cyclopropane, or I would have cyclohexane. Okay, then we would have aromatic compounds also. One of the common structures which you already would know or would have heard about is a benzene ring, a benzene structure. Okay, so these are different ring structures in which again carbon can exist or can form. So we have a straight chain compound, a branched structure, or a ring structures or cyclic structures, we would say. Okay. So this is all about the introduction of carbon. For the functional groups, we will definitely see it in next video.